Okay, example 5. Find the zeros of the given polynomial function, give the multiplicity for each zero, state whether the graph crosses the x-axis or touches and turns the x-axis, or touches the x-axis and turns around at each zero. I should learn how to read. Okay, when it says find the zeros, that tells me to set equal to 0 and solve. And come test time, if all you know is that, at least write that down. You've shown me something. If you can write down something correct, you will probably get a point. So, x cubed plus 6x squared plus 9x equals 0. It's a polynomial equation. We haven't discussed that in a while, but the steps to a polynomial equation, set equal to 0, we got that. Factor. So we got the set equal to 0 factor. I can start by taking out a greatest common factor of x. Now notice I factored out x. I did not divide by x. You should never divide by variables. When you divide by variables, you will lose the solution x equals 0, or y equals 0, or t equals 0, whatever your variable happens to be. You will lose the solution of 0 because when you divide by that variable, since division by 0 is illegal, since division by 0 is undefined, you are making the declaration that it can't be 0. Because since you can't divide by 0, you're making the declaration, I know this won't be 0. So don't divide by variables. Factor out variables. Then this factors again to x plus 3, x plus 3. It is now factor and equal to 0. So I can set each factor equal to 0. And I get x equals 0, x equal negative 3, x equal negative 3. So there are my zeros. Then we'll answer the rest of it by making a chart. So in the first column, my 0. In the next column, it's multiplicity. And then whether it crosses the x-axis or touches and turns. So my first 0 happens to be the number 0, just a kind of little coincidence there. It appeared once when I was solving this. I only came up with that answer once. So its multiplicity is 1. Now in order to do the next part, what I'm more concerned with, not so much that it's 1, but it's odd. And because the multiplicity is odd, that tells me that when I graph it, or if I were to graph it, it's going to touch and turn the x-axis. My next 0, x equal negative 3. And when I solve that equation, that answer came up twice. So the multiplicity is 2. And what I care about mostly there when I go on to the next column is whether that's even or odd. That's even, which tells me, oops, I got this backwards. I made a mistake, and I'm not even going to pretend that I did anything but other make a mistake. So I'm going to wipe that out. I'll apologize for the mistake. So let's go back here, redo this part. So my 0 was x equals 0. That answer appeared once, so it's multiplicity 1. It's odd. And when my multiplicity is odd, it crosses the x-axis. Big old mistake on my part. Odd multiplicities cross. Then doing the next one, my multiplicity is negative 3, or excuse me, my 0 is negative 3. That appeared twice as I do that, which means my multiplicity is 2, which is an even number, and even multiplicities are touch and turn. Got that right. Okay, beating this to death a little bit more. Again, we're working up to graphing. And so what this does for us is it tells me my x-intercepts. Remember, zeros are essentially the same thing as x-intercepts. So it's telling me my x-intercepts, then it's telling me what the graph is doing there. that it crosses at x equals 0 and touches and turns at x equals 3. And we're building towards graphing. So we solved the previous problem. We factored it. I could have, I know I did not do this, but I could have if I wanted to. We factored it, and we factored out the x, and we said that's x plus 3, and that's where we stopped. But I could have rewritten that way. I could have collected the x plus 3s as x plus 3 quantity squared. And I could have, if I wanted to, we didn't, I could have said that was x plus 1 quantity squared. But remember what we said before. And then one of the reasons why I'm rewriting it is our multiplicities are coming from those exponents. X equals 0 had a multiplicity of 1. And if I'm really specific, there's my exponent of 1. My multiplicity of x equal negative 3 was 2. There's my exponent of 2. And so that's why I've rewritten it explicitly, getting those exponents in there. And then I could have done one more step. Instead of just saying x, I could have said x minus 0, because subtracting 0 doesn't change anything. But again, the idea that I can then read off my zeros. Now, I also could have put plus there, it doesn't matter. But then once it's in this factored form, I had a 0 of 0, just taking that number right in there, and negative 3, taking the opposite there. That if I can get it down into this factored form, I can absolutely read off the zeros by just taking the opposite of the numbers inside, and I can read off their multiplicities. And so that's one of the things we want to observe. And then we want to also observe that each 0 has an associated factor. So that as soon as I knew that x equals 0 was a 0, I knew that I'd have a factor of x minus 0. And when I knew that x minus 3 was a 0, I knew that I would have a factor of x plus 3. That if you have it factored, you know the zeros. And if you know the zeros, you know how to factor. You can go both directions. That if it is factored, you can find the zeros. But if you only know the zeros, you can say how it factors. That there's that relationship there between the zeros and the factoring. So going back to those three equivalencies that we had before, if one of the following statements is true, all the statements are true. The number c is a function, if the number c is a 0 of f of x, which means the exact same thing as saying f of c equals 0, which is the exact same thing as saying the point c0 is an x-intercept, which is now the exact same thing that when it's factored, I will have x minus c as a factor. That if you know a 0, you know a factor. If you know a factor, you know a 0. That if c is a 0, then you're going to have the factor x minus c. And if you have the factor x minus c, you know that c is a factor, or c is a 0. But all those things are equivalent. So now what we've been building to, graphing things like this. And again, somewhat old-fashioned here, because we do have a machine. But machines are only as good as the data you give them. And so this helps us get some data sometimes, but I wouldn't stress greatly. We are, in the end, going to help a machine do. We are going to let a machine help us with the graphing here. So letter A here, use the lead coefficient test to determine the graph's end behavior. So lead coefficient test did two things. We needed the degree, which happens to be 4. And what we cared about that was whether it was even or odd. That is even. The lead coefficient, well, that's going to be negative 1. And what I cared about there was it was negative. And so my little example that I think of would be y equals negative x squared. And then I think of what that graph looks like. And so that tells me that my end behavior is falls left, falls right. And that honestly is how I do the problems. I don't memorize even, odd, negative, positive. I'll memorize all that and make myself a little example and think about the picture. Then the picture tells me my answer. Okay, next thing to do with this one. Find the x-intercepts. State whether the graph crosses the x-axis or touches and turns at x-intercepts. When it says x-intercept, that is set equal to 0 and solve. So we have negative x to the 4th plus 4x squared equals 0. Polynomial equation just like before. Let's factor. Again, don't divide by variables. Factor out variables. So I factor out a negative x squared. And then I could very explicitly do this if I wanted. You don't have to do that, but I'll do it. Instead of writing x squared, I could write x minus 0 quantity squared. And then this next guy factors to x plus 2, x minus 2. And then very, very explicitly, first and first. And from there, I can answer the rest of the problem. That my x-intercept, spelling that wrong, and so we'll abbreviate just x-int, x-intercept, which is the same thing as 0, my 0. The multiplicity, which it didn't ask for, but I'm going to give it, and then whether it crosses or touch turn. Okay, so I can read off my zeros by just looking inside here. So I look inside the factor that says x minus 0. I would take the opposite. Well, 0 is just 0, so 0. Then my multiplicity is my exponent, and so my multiplicity is 2, which what I care about there is that's even. And because it's even, that means we touch and turn. I'm having problems writing today. Touch, turn. Then I can look right here, take the opposite, plus 2. So my 0, or my x-intercept, is going to be minus 2. Then my multiplicity right there, 1, which is odd. Odd multiplicities cause me to cross. And then again, right there, take the opposite. So my x-intercept, or my 0, is 2. Look right there for the multiplicity. It's 1, which again is odd, which means we cross. And there's the answer to that one. Then find the y-intercept, always and forever. Plug in x equals 0. So y will be f of 0. So negative 0 to the 4th plus 4 times 0 squared for 0. Determine whether the graph has y-axis symmetry, origin symmetry, or neither. Now the reason why it's in here is that when you do the homework, it's in the homework. So we have a little recall here. Recall, we did not discuss algebraic ways to determine symmetry. Use a graphing calculator to graph the function and then determine the symmetry using the graph. So we will come back to this problem. But warning you that when you go and do the homework, this problem is going to creep up first. And so you're going to have to kind of shortchange things. Take a machine out, graph it, then answer that question by looking at the graph. And if you don't have a graphing calculator, just use something from the web. Desmos is it's a free online graphing calculator sort of thing. Then determine the graph of the function. And so we will do that on the next video.